Alright, I hope y'all had a great weekend. By now you should have completed warm-up number 5, so make sure you've done that and make sure your phone is also in the back like it probably already is. So we're going to move on to section 1.2, and this deals with functions. We talked a little bit about functions last week, but we didn't get into great detail about them. But remember, functions are different than other equations. So, if we have a relation, this is pairs of quantities that are related to each other by a rule of correspondence. And this is known as a relation. So a relation can be any equation that you come up with. But if you have a function, then that function from set A to set B is a relation that assigns each element x in the set A exactly one element y in the set B. So that's where for every x you have, it can only correspond with one y. And we're going to explain this a little more, so if these definitions seem confusing, just be patient. So remember, the domain is the set A of the function, and we typically know it as all of the x's. And then the range of the function is set B, and typically we call that all of the y's. Input is the same thing as the domain. Output is the same thing as the range. The independent values are the domain, and the dependent values are the range. So just remember all those terms because we're going to reference those a lot throughout the section. So, characteristics of functions from set A to set B, and you can find this on page 16 in your book if you want more information. But each element of A must be matched with an element of B. Some elements of B may not be matched with any elements of A. So if I have two sets, we've got A and B. I'm right on my computer screen, so you're going to have to bear with me. I'll get better at it, I promise. So if I have 1 going to 4, then that means 1 cannot also go to -5. But I could have 2 go to 4 and 3 go to 6 and nothing going to -5, and that would be fine. But I can't have one of these numbers over here in A by itself. It has to have a match. 2 or more elements of A may be matched with the same element of B, like we have here. 1 and 2 are both going to 4. An element of A cannot be matched with 2 different elements of B. So we could not have 1 going to -5, also, or that would not be a function. So if you look at these examples, we want to decide if these relations are functions. So if we look at this first example, if you look in set A, you want to make sure every element is only going to one element of B. And if you look, they are, so this would be a function. And then if we look at number 2, you should automatically see right here, this is going to 2 elements, so this is not a function. And then 3, we've got these numbers. Well, we've got 3's repeated for x 2 times, and 2's repeated, and 1 is repeated, and they have different y's that they're paired with, so this is not a function. And then here we've got 3 different inputs. They're all going to the same output, which is okay, so this is a function. So remember, each input has to be paired with a different output. The same output could go to a different input, but each input has to have a different output. So we've got to decide if these ordered pairs represent functions from A to B. So if I have 0 with 1, 1 with -2, 2 with 0, and 3 with 2, would that be a function? And we're pulling those numbers from here. So yes, this would be a function because all of the inputs are paired with exactly one output. And all of the inputs are used. Then if we look at the second example, we've got 0 going to 0, 1 going to 0, 2 going to 0, and 3 going to 0. Well, each input is only used once and is paired with one output. Even though they're all going to the same output, that's okay. So this is also a function. This should be familiar to you. You've covered this in Algebra 1 and also Algebra 2, so this should be a review. Alright, so we're going to figure out which of the equations represent y as a function of x. So we're going to have an equation and we have to figure out whether or not it's a function. So the first step that you take is you're going to solve for y. Then you have to decide whether or not each value of x corresponds to exactly one value of y. If it does, then it's a function. If not, then then it is not a function. So we look at this first example, x squared plus y squared equals 4. We need to solve for y. So we're going to subtract x squared. Well, I just subtracted it and I wrote it again. So we'll have y squared equals negative x squared plus 4. And then to get y by itself, we would want to take the square root of both sides. So we're going to have y equals, whenever you take the square root, we have to remember to take the positive and negative of that square root. Negative x squared plus 4. Well, is every value of x going to give us exactly one value for y? Well, if you look, when I plug in a number for x right here, we're going to get a positive and negative, so that's two different outputs, so this is not a function, because we would get two different outputs because of the plus or minus. All right, then for the second equation, you should look at this and automatically know it's linear. Well, if it's linear, we can solve it for y. And we can tell if we put in an x value, we're only going to get one y value, so yes, this is a function. All right, for this last one, we've got an absolute value problem. So we've got to decide, is this going to, for every input, are we going to get exactly one output? So if we think about this, if you remember, the absolute value graphs are V-shaped. So if we plug in any number for x, say we plug in 1, then we're going to get 4 minus 1, which is 3, and the absolute value of 3 is 3. Is there any number we can plug in and get two different answers for y? There isn't one, so this is also a function. So make sure you remember you solve for y for those and then figure out, is there any x value I can plug in where I would get two different answers? All right, function notation. You should remember function notation is where we use f of x, you can use g of x, you can use g of y, you can use any letters using that notation. So if I have f of x equals 15 minus 3x and I want to know f of 0, that means I take 0 and substitute it in for x. So that would be the same thing as 15 minus 3 times 0, which would be 15 minus 0, which is just 15. So if I want f of 2, I do the same thing with 2. So I'm going to have 15 minus 3 times 2, which is 15 minus 6, which is 9. So f of 2 equals 9. And for f of negative 3, we do the same thing. 15 minus 3 times negative 3 is the same thing as 15 plus 9, which is 24. So you should remember function notation. I just wanted to review it. So for g of y equals 6 plus y squared, to find g of negative 3, we just take that and plug it in for y. So that would be 6 plus 9, which is 15. All right, then for this type of function, this is where we have three different parts. So this is called a piecewise function. And depending on what the value is, you decide which part of the equation you would use. So for f of negative 2, well, we look right here at this section. And for f of negative 2, we know negative 2 falls in this part. So I'm going to take negative 2 and I'm only going to plug it into this equation. So this would be negative 2 plus 2, because I plugged it in x plus 2, which would be 0. Then if I want to plug in 1, we know 1 is between 0 and 2. And that goes with the function equals 4. So where f of for f of 1, you just plug it into 4, which means the answer is just 4. And that's because 1 is between 0 and 2. And then for f of 4, that's greater than 2, so we're going to look at this part. So we're going to use this part of the function. So that would mean 4 squared plus 1, which is 16 plus 1, which is 17. So when you have a piecewise function, look at the number you're substituting in, the function value you're plugging in, and figure out what part of the function you should be using. You're not going to use all 3 parts at one time. Alright, find the real values of x such that f of x equals 0. So this is going to be different because if f of x equals 0, then that means I'm taking 0 and substituting it in for f of x. So in this equation, we would, instead of f of x, put 0 equals 3x minus 4 over 5. So there's several ways you could solve this, but I'm going to put 0 over 1 and cross multiply. So 0 times 5 would give us 0. 3x minus 4 times 1 would give me 3x minus 4. And then to solve, we add 4. And divide by 3. So x equals 4/3 when f of x equals 0. So if you think about that, that's basically saying, okay, f of x equals 0, so then x equals 4/3. Well, x is the same thing as y, so this is really like having the point 4/3, 0. That's basically your x-intercept. Then we've got find the real values of x such that f of x equals g of x. So if you feel like this is a lot of different examples I'm showing you, it is because I want to make sure you understand how to work out the different types of problems you're going to see. So if we want f of x equal g of x, we take what f of x is equal to, substitute it in for f of x, and substitute what g of x is equal to. So we'll have x squared equals x plus 2. And so we need to move everything to one side. So we're going to subtract x and subtract 2. And the easiest way to do this is going to be to factor or reverse FOIL, which is why I gave you the warm-up problems I did, so that it would help you remember how to do this. So we need factors of -2 that would add to give us -1. Which would be x minus 2 and x plus 1. But you're not finished, you have to actually solve for x. So we're going to take x minus 2 and set it equal to 0, and x plus 1 and set it equal to 0. So for this equation, we would get x equals 2, and for this one, we would get x equals -1. And so both of those answers would be correct. And you could check them and make sure 2 squared is 4, 2 plus 2 is 4. -1 squared is 1, -1 plus 2 is 1. So both are correct. Alright, so here is your assignment. So I want you to get started on that. Make sure you show your work where needed. And if you have questions about something, you need to write down what your question is. Tomorrow I'll be back and we'll go over all of this and everything from Friday. So hope y'all have a good day, good luck, and get to work.